After studying this module, we shall be able to use the algebraic method to do break-even analysis, to calculate break-even point in units and in value with relevant information, draw a break-even chart with given information and data, evaluate cash, financial, and composite break-even point, calculate break-even capacity of merged plants, margin of safety, and angle of incidence. Break-even analysis is an important technique of CVP analysis. Break-even analysis may be defined as a mechanism wherein the relationship among the variables, namely cost of production, volume of production, sales, and profit is determined, and a detailed analysis is done as to see the effect on profits due to changes in these variables. The break-even analysis helps to determine the probable profits at any given level of activity or output. The break-even point is the sales level at which the contribution margin is just equal to the fixed cost and the firm has no profit and no loss. At break-even sales level, the total cost, that is the fixed cost and the variable cost, are just covered. Any sales level below the break-even point will therefore result in loss, and the sales level above the break-even point will bring profits to the firm. Once the break-even sales are achieved, the net profit will increase by the unit contribution. Break-even sales level may be computed for a product or for a group of the product or for the entire firm. All the costs, that is the fixed cost or the variable cost of the manufacturing or non-manufacturing operations, must be incorporated in the calculation of break-even point. It may be noted that the break-even sales level is the minimum sales level the firm must achieve to incur no loss, but in no case it is taken as a desirable sales level. No firm in the long run can survive by operating at the break-even point of sales only. The break-even analysis may be explained in mathematical mode in the form of break-even equation or in graphical mode. The break-even equation may be derived from the basic relationship between sales and profit. We know that net profit is equal to sales minus variable cost minus fixed cost, or sales is equal to variable cost plus fixed cost plus net profit. We also know that sales is equal to number of units sold multiplied by selling price. Thus, we can represent the equation as N multiplied by SP, that is selling price, is equal to N multiplied by variable cost per unit plus fixed cost plus net profit, that is N multiplied by selling price is equal to N multiplied by variable cost plus F fixed cost plus NP net profit. As we know, at the break-even level, the profit is 0, that is, NP is 0. Therefore, the equation can be written as N multiplied by SP selling price is equal to N multiplied by variable cost plus fixed cost F. Or we can say that N multiplied by selling price minus variable cost is equal to fixed cost, that is F, or N is equal to fixed cost divided by selling price minus variable cost, and we know that selling price minus variable cost is equal to contribution margin per unit. Thus, we can say that N is equal to fixed cost divided by contribution margin per unit. Thus, break-even point in units is equal to fixed cost divided by contribution margin per unit, and break-even point in value is equal to fixed cost divided by contribution sales ratio. We can also say that break-even point in value is equal to fixed cost divided by PV ratio, that is profit volume ratio, where contribution sales ratio or PV ratio is equal to contribution margin divided by sales multiplied by 100. Thus, we see that the break-even analysis can be done by determining the value of one or more of these variables. If the selling price is known, we can find out the number of units to be sold to break even. If number of units expected to be sold are known, we can use this equation to find out the minimum selling price to break even. Let us use the understanding that we have developed to a simple example here. Suppose XYZ Limited manufactures files for office use. The breakup of its cost and sales is given in the table, which is variable cost per file is equal to rupees 40, fixed cost is equal to rupees 60,000, selling price is equal to rupees 100 per file. Let us compute the break-even point in units as well as in value. We can find out contribution per file by subtracting variable cost per file from selling price per file. That is, contribution per file is rupees 100, that is the selling price, minus rupees 40, that is the variable cost per file. Thus, contribution per file is rupees 60. We know that the formula for computing break-even point in units is break-even point is equal to total fixed cost divided by contribution per unit. In our example, total fixed cost is given as rupees 60,000 and we have calculated the contribution per unit as rupees 60. Thus, substituting these values in the formula, we get break-even point is equal to rupees 60,000 divided by rupees 60, that is 1000 files. Let us now compute the break-even point in value, that is in rupee terms. The formula for break-even point in value is break-even point is equal to total fixed cost divided by PV ratio, where PV ratio is equal to contribution per unit divided by selling price per unit whole multiplied by 100, which is equal to 60 divided by 100 whole multiplied by 100, that comes out to be 60%. Substituting this value in the formula, we arrive at the break-even point in rupees as 60,000 divided by 60%, that is rupees 1 lakh. Now we know how to calculate break-even point in units and value. Let us move ahead to understand the break-even graph. The break-even chart or graph may be drawn by considering and taking the following steps. Volume in number of units is taken as the horizontal axis and the costs and sales revenues are taken on the vertical axis. A parallel line to the volume axis, that is horizontal axis, is drawn to represent the fixed cost. Draw a total sales line starting at the origin and increasing at the rate of selling price per unit. Draw a line that starts at the level of fixed cost on the vertical axis and increases at the rate of variable cost per unit. This line represents the total cost function, and the difference between this line and the fixed cost line at any level of output is the total variable cost at that level of output. If the contribution margin at different levels of output is also required to be displayed by the break-even chart, then draw one more line starting from the origin and increasing at the rate of variable cost per unit. This line shows total variable cost for different levels of output. The difference between the total sales line and the total variable cost line shows the contribution margin at different output levels. The point where TR line, that is the total revenue line, and the total cost line intersects is the break-even point. The area between total cost and total revenue below the break-even point represents losses, and the area between total revenue and total cost above the break-even point represents profits of the firm, and at the break-even point total revenues is equal to total cost, that is, there are no profits and no loss. The angle made by total cost line and total sales line is called the angle of incidence. Large angle of incidence shows higher profit rate. Let us now draw the break-even chart for a given set of information whereby fixed cost is equal to rupees 6 lakhs, variable cost per unit is equal to rupees 40, selling price per unit is equal to rupees 70. To draw the break-even chart, we first need to work out the relevant costs, that is, the fixed cost, the variable cost, and the total cost, and sales at various levels of output as shown in the table. From the figures so arrived, break-even points are of three types, that is, cash break-even point, financial break-even point, and the composite break-even point. Cash break-even point is applicable in the case of operating plant. It is that level of sales where total cash inflows is just equal to total cash cost. Firms are in serious cash flow condition before this point. Financial break-even point is that level of sales at which earning per share is zero. At this point, the firm has earning before interest and taxes, that is EBIT, which is just sufficient to cover all fixed financial charges, for example, interests and preference dividend. The third type of break-even point, that is, the composite break-even point, is applicable only for those firms which manufacture more than one product. Here, the break-even point calculations consider all the products together. We will cover each of these in details with the help of examples. Cash break-even point refers to that level of output and sales at which total cash cost is equal to total sales revenue. At this point, there is neither cash revenue nor cash loss to the firm. The firm is able to just manage the immediate cash requirements from the cash inflows. Thus, it is an important concept for an operating plant. Below this point, the producer is in real difficulty. For the purpose of cash break-even point, cash fixed costs are accounted for. This cost is reached by reducing all non-cash fixed cost from total fixed cost. The stepwise solution of the problem to calculate cash break-even point has three steps. These steps are: Step 1. Cash fixed cost is calculated by reducing non-cash cost from the total fixed cost. Step 2. Cash break-even point in unit can be calculated by dividing cash fixed cost by cash contribution per unit. Step 3. Cash break-even point in value can be calculated by dividing cash fixed cost by PV ratio. Let us see how cash break-even point is calculated with the help of an example. Let us assume that the total fixed cost of a firm for the year 2013-14 is rupees 18,60,000, which includes a depreciation of machinery amounting to rupees 2,50,000, notional rent of the building rupees 1,50,000, and a deferred revenue expenditure of rupees 60,000. The selling price per unit is rupees 250 and the variable cost per unit is rupees 150. Cash contribution per unit can be calculated by subtracting variable cost per unit from selling price per unit, that is rupees 250 minus rupees 150, which comes out to be rupees 100. We can work out the amount of cash component of fixed cost by subtracting non-cash fixed cost from the total fixed cost. As per the given details, the non-cash fixed cost equals to the sum of depreciation, that is rupees 2,50,000, notional rent, that is rupees 1,50,000, and the deferred revenue expenditure, that is rupees 60,000, which comes out to be rupees 14 lakhs. Now, putting these values in the formula for cash break-even point in units, that is cash fixed cost divided by cash contribution per unit, that is 14 lakh divided by 100, which is equal to 14,000 units, and cash break-even point in rupees is equal to 14,000 units multiplied by rupees 250, which is the selling price, and it comes out to be rupees 35 lakhs. We can also work out the cash break-even point in value by using the formula, that is by dividing cash fixed cost by PV ratio as shown here. Financial break-even point is that level of earning before interest and taxes at which firm covers all financial charges. At this level, firm's earning per share is zero. Below this point, the firm's earning per share is negative. However, once firm achieves financial break-even, the earning per share rises disproportionate to changes in EBIT, that is earning before interest and taxes, as it gives a good indication about earning per share for the firm and thus financial risk associated with the firm. It is a very useful measure. Let us see how financial break-even point is calculated with the help of an example. The stepwise solution of the problem to calculate financial break-even point has three steps. These steps are: Step 1. Calculate interest. Step 2. Calculate preference dividend. Step 3. calculate financial break-even point by using the formula as shown here, where I is equal to interest, PD is the preference share dividend, and T is the tax rate. Let us see how financial break-even point is calculated with the help of an example. Let us assume that the following information is available in respect of a firm. Share capital, equity shares of rupees 10 each, and the amount of share capital is rupees 7 lakhs. 12.5% preference shares of rupees 100 each, the amount is rupees 3 lakhs. 15% debentures, amount rupees 2 lakh. Tax rate 40%. Now, interest on debentures is equal to 2 lakh multiplied by 15 divided by 100, which is equal to 30,000. Preference dividend is equal to 3 lakh multiplied by 12.5 divided by 100, which comes out to be 37,500. Thus, the financial break-even point is equal to interest, that is I, plus preference dividend, that is PD, whole divided by 1 minus T, that is tax rate, which is equal to 30,000 plus 37,500 divided by 1 minus 0.4, which is equal to 92,500. Composite break-even point is applicable for the firms which manufacture more than one products. To compute break-even point in this case, the key problem is that in what proportion the sales of different products would take place. There can be two cases for it. 1. When the product mix is constant, wherein the ratio of different products which are manufactured remains constant at all output levels, and 2. When the product mix is variable, wherein products in decreasing order of contributions are manufactured. Let us see the stepwise solution of the given problem to find the composite break-even point. Individual contributions from all the products are added to arrive at total contribution for composite break-even point as shown in the table, such that the total contribution comes out to be rupees 65,000 and the total sales are rupees 1,70,000. Now, with this, we can arrive at the composite PV ratio, that is 65,000 divided by 1,70,000 multiplied by 100, which comes out to be 38.2%. Now, the next step is to calculate the composite break-even point by dividing the total fixed cost by this composite PV ratio, that is 15,000 divided by 0.38, which is equal to rupees 39,474. The margin of safety is the difference between total sales, that is the actual or projected sales, and the break-even sales. Low break-even point may leave a higher margin of safety. It may be expressed in the monetary terms or as a percentage of actual total sales. Margin of safety is equal to actual sales minus break-even sales. Margin of safety in units is equal to profit divided by contribution per unit, or margin of safety in percentage terms is equal to actual sales minus break-even sales whole divided by actual sales multiplied by 100. Margin of safety can also be calculated with the help of PV ratio as margin of safety is equal to profits divided by PV ratio.
Margin of safety is a valuable parameter to the strength of the business firm. If margin of safety is low, then a small unfavorable change in the sales can turn the business firm into losses. Hence, a firm needs to maintain a satisfactory margin of safety using single or a combination of applicable suggestions. The size of margin of safety is an extremely valuable guide to the strength of any business firm. It indicates by how much sales may decrease before a loss occurs. If large, this means that there can be substantial falling of sales and yet a profit can still be made. It is a sign of soundness for any business firm since even with a substantial reduction in sales, profit is earned by the business firm. On the other hand, if the margin of safety is small, any loss may be a serious matter. Low margin of safety implies that reduction in sales, even by a small amount, may affect the profitability of the firm adversely. Margin of safety serves as an indicator of strength of the business firm.
If the margin of safety is unsatisfactory, possible steps to rectify the matter are given as number 1. Increase in selling price. For this to be possible, the company must be in a very strong and favorable position. It should be able to influence the price charged. The demand must be inelastic, otherwise, the same quantity will not be sold. Number 2, reduce the fixed cost. Number 3, reduce the variable cost. Number 4, substitution of existing product or products by more profitable product lines. Number 5, increase the volume of output. Angle of incidence is the angle at which the sales line cuts the total cost line. A large incidence angle indicates that profits are being made at high rates. Together with margin of safety, it indicates an extremely favorable position and sometimes may indicate monopolistic conditions. The smaller angle of incidence indicates that while profits are being made, they are being made under less favorable conditions.
Break-even point is the level of output at which total costs equals the total sales revenues and the firm is in no profit and no loss situation. Break-even point is computed as total fixed cost divided by contribution per unit multiplied by total sales. A break-even chart is the graphical presentation of the relationship between cost, selling price, volume of output and profits of the firm. It shows the behavior of costs and revenues for different levels of output. Margin of safety is the excess of actual level of sales over the break-even sales. A higher margin of safety shows lower risk and is thus preferable. Angle of incidence is the angle made at the intersection of total cost and total sales lines in a break-even chart. A large angle of incidence shows higher profits of the firm.